The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observed in this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I'll respond as soon as I can. All right, today we're going to take a look at section 8.5, which is solving absolute value equations. First of all, let's do some review as to how absolute value works. Absolute value of a number is the distance from that number to 0 on the number line. So for instance, the distance from 7 to 0 is 7. So we say the absolute value of 7 is 7. The distance from -7 to 0 is also 7, or the absolute value of -7 is 7. Distance is always positive with one exception, and that is the absolute value of 0 is 0. So an absolute value of 0 is 0. An absolute value of any non-zero number is going to be a positive number. Okay? Any questions about that? So if the absolute value of 7 is 7, and the absolute value of -7 is 7, suppose we had the following absolute value equation. What if we said the absolute value of x was 7? Yeah, okay. So the absolute value of x is 7. What possible values could x be? Well, we can see from over here that x would be 7, or x could be the opposite of 7, okay? So basically, it can be the number out here or the opposite of the number out there. Any questions about that? All right. Suppose we had the following equation. The absolute value of x is 14. What values could x be? Well, x could be 14, or x could be the opposite of 14, because the absolute value of 14 is 14. The absolute value of -14 is 14. Any questions on that? All right. What if we had the following? The absolute value of x plus 2 is 10. Well, that would mean that what's inside would either equal 10, or what's inside would equal the opposite of 10, or -10. You still with me? Still following this? Well, nobody's saying no, so I'll say, okay, just making sure. So let's go back and solve each of these equations. If x plus 2 equals 10, subtracting 2 from both sides, we get x equals 8. If x plus 2 equals -10, subtracting 2 from both sides, we get x equals -12. Let's check our work. Let's plug each of these in to the original equation. All right. So the absolute value of x plus 2 equals 10. Excuse me, but x is now 8. So 8 plus 2 is 10. The absolute value of 10 equals 10. Well, the absolute value of 10 is 10. So 10 equals 10, and it checks. What if x is -12? We get the absolute value of -12 plus 2 equals 10. -12 plus 2 is -10. The absolute value of -10 is 10. 10 equals 10, and it checks. So we get 2 solutions. Any questions so far? Okay. How about this one? The absolute value of 2x minus 6 equals 14. So that means that what's inside the absolute value bars has to either equal 14 or equal -14, because the absolute value of -14 would be 14. So we have 2x minus 6 equals 14, or 2x minus 6 equals the opposite of, or -14. Solving the first equation, we'll add 6 to both sides. 2x equals 20. divide by 2, x equals 10. Solving the second equation, add 6 to both sides, 2x equals -8. Divide both sides by 2, x equals -4. Let's check our work. If x is 10, we'd have the absolute value of 2 times 10 minus 6 equals 14. 2 times 10 is 20. 20 minus 6 is 14. The absolute value of 14 is 14. So 14 equals 14, and it checks. If x is -4, the absolute value of 2 times -4 minus 6 equals 14. 2 times -4 is -8. -8 minus 6 is -14. The absolute value of -14 is 14. So 14 equals 14. It checks. Am I going too fast?
No.
Okay, all righty. What about this? What if we had the absolute value of 2x minus 3 equals 0? So if instead of it being equal to a positive number, it's equal to 0. Well, that means that what's inside would have to equal 0, or what's inside would equal the opposite of 0. But isn't the opposite of 0 still just 0? So in fact, when it's set equal to 0, we really only have one possible equation. What's inside equal to 0. Solving for x, we get 2x equals 3. Divide by 2, x equals 3/2. Let's check our work. The absolute value of 2 times 3/2 minus 3 equals 0. 2 times 3/2 reduces down to 3. 3 minus 3 is 0. The absolute value of 0 is 0. So 0 equals 0, and it checks. So again, if it's set equal to a positive number, we have two possible equations. If it's set equal to 0, we have just one possible equation. What if it's set equal to a negative number? How about, let's see, 4x minus 8 equals, the absolute value of 4x minus 8 equals -6. Okay. Well, let's see. That means that either 4x minus 8 equals -6, or 4x minus 8 equals the opposite of -6. On the left side, we'd add 8 to both sides. 4x equals 2. Divide by 4, x equals 1/2. On the right side, we'd get 4x minus 8 equals, the opposite of a negative is a positive, so that becomes a 6. Add 8 to both sides. 4x equals 14. Divide by 4, x equals 7/2. So we've got x equals 7/2, x equals 1/2. Let's check the 1/2. So we've got the absolute value of 4 times 1/2 minus 8. Minus 8 equals -6. 4 times 1/2 is 2. 2 minus 8 is -6. The absolute value of -6 is 6. So we get 6 equals -6. Well, that's not true. So that's not a solution. How about x equals 7/2? The absolute value of 4 times 7/2 minus 8 equals -6. 4 over 2 is 2 over 1. 2 times 7 is 14. 14 minus 8 is 6. The absolute value of 6 is 6. 6 equals -6. So there's no solution, or no solution. Now, if we think about it, I said earlier that absolute value is either 0 or positive. So from the get-go, we could see that there's going to be no solution. Sometimes WebAssign, however, will ask you to find these non-solutions, to identify them, and then to say whether they work or not. So be sure to read carefully on your problems. Okay. So what if we have a situation where there is, let's say, an absolute value and some other stuff on the same side of the equation? Okay, what if you've got something like this? Well, what you need to do, your first goal is to isolate the absolute value expression, and then consider splitting it up into two possibilities. So my first move here is going to be to subtract 30 from both sides of the equation. So then I get the absolute value of x minus 10 equals 20. Now that I've isolated the absolute value, I have x minus 10 equals 20, or x minus 10 could equal the opposite of 20, or negative 20. Solving each individual equation, the first one, we'll add 10 to both sides, x is 30. The second one, we'll add 10 to both sides, x is negative 10. Let's check our work. If x is 30, we get the absolute value of 30 minus 10 plus 30 equals 50. 30 minus 10 is 20, and the absolute value of 20 is 20. 20 plus 30 is 50. 50 equals 50, so it checks. How about x equals negative 10? The absolute value of negative 10 minus 10 plus 30 equals 50. Well, negative 10 minus 10 is negative 20, but the absolute value of negative 20 is positive 20, and 20 plus 30 is 50. 50 equals 50, so they both check. But we want to make sure to isolate the absolute value term before you split things apart. Okay, what about this situation? We've got negative 10 times the absolute value of 16x plus 4 minus 3 equals negative 3. So again, I need to isolate the absolute value expression. So my first move is to add 3 to both sides. So now I have negative 10 times the absolute value of 16x plus 4 equals 0. We need to get rid of that negative 10 coefficient out front. So we'll divide both sides by negative 10. We now have the absolute value of 16x plus 4 equals, well, 0 divided by negative 10 is 0. So now we have an absolute value set equal to 0. So there's going to just be the one possible equation. Subtracting 4, 16x equals negative 4, divide by 16x equals negative 1/4. Let's plug that in. Let's see, negative 10 times the absolute value of 16 times negative 1/4 plus 4 minus 3 equals negative 3. 16 times negative 1/4 would be negative 4. Negative 4 plus 4 is 0. So I've got negative 10 times, but the absolute value of 0 is 0. Negative 10 times 0 is 0. 0 minus 3 is negative 3. Negative 3 equals negative 3. Yes, so it checks. Okay. What about if we have two absolute value expressions? The absolute value of 4x plus 3 equals the absolute value of 9 minus 2x. All right. Now, we could look at four possibilities. We could take what's inside of the first one and set it equal to what's inside of the second one. We could take what's inside the first one and set it equal to the opposite of what's inside the second one. We could take the opposite of what's inside the first one and set it equal to the opposite of what's inside the second one. Or we could take the opposite of what's inside the first one and set it equal to the second one. Think in terms of something like that's true, that's true, that's true, and that's true, right? But going back and looking at these four equations, if we compare equation 1 and equation 2, if I took equation 1 and I multiplied both sides by -1, wouldn't I have equation 3? Therefore, they're redundant, they're the same equation, so I can get rid of that. Well, what about equation 2 and equation 4? If I took equation 2 and multiplied both sides by -1, I'd get equation 4. So they're redundant. So what does that bring us back to? Well, let's see here. Oops, I erased more than I wanted to there. I'll have to fix it. Basically, we have the same two scenarios we had before. What's inside equals what's inside equals the opposite of what's inside, okay? Because the other two equations are redundant, the same as what we have here. So now, let's go back. And we'll write the other equation like that. So what's inside of the first one equals what's inside of the second one, or what's inside of the first one equals the opposite of what's inside of the second one. Solving each equation, solving the first equation, we'll add x to both sides. 6x plus 3 equals 9, subtract 3. 6x equals 6, divide by 6, x equals 1. Taking the second equation, we'll distribute this negative sign, -9 plus 2x. Subtract 2x from both sides. 2x plus 3 equals -9. Subtract 3 from both sides. 2x equals -12. Divide by 2, x equals -6. Well, let's check our work. If x is 1, see if we can squish that in here. We get the absolute value of 4 times 1 plus 3 equals the absolute value of 9 minus 2 times 1. 4 times 1 is 4. 4 plus 3 is 7. The absolute value of 7 is 7. 2 times 1 is 2. 9 minus 2 is 7. The absolute value of 7 is 7. So x equals 1 works. Let's try this second one here. X equals -6. The absolute value of 4 times -6 plus 3 equals the absolute value of 9 times 2 times -6. 4 times -6 is -24. -24 plus 3 is -21. The absolute value of -21 is 21. 9 minus 2 times -6 is like 9 plus 2 times +6, which is 9 plus 12, which is 21. And the absolute value of 21 is 21. So they both work. All right. So if you have an expression or an equation with one absolute value term, isolate it completely, get rid of any coefficient in the front, any other terms outside, isolate it before you split it up. If it's set equal to a positive number, you should come up with 2 different equations to solve. If it's equal to 0, you should come up with 1 equation to solve. If it's equal to a negative number, you're not going to get any solutions, but you could go through and try and solve it. And then when you check your work, you'll see that they don't work. If you have an equation with 2 absolute values, you want them separate on both sides of the equation. Let's look at another example here. Okay. Let's see here. The absolute value of 3x plus 4 equals the absolute value of 3x minus 7. Okay. So that means I've got 3x plus 4 equals 3x minus 7, or 3x plus 4 equals the opposite of 3x minus 7. Solving the equation on the left, we'll subtract 3x from both sides, and I get 4 equals 7. That's a false statement, so that is not a solution. Okay. Let's take the other one, or there is no solution to that equation, I should say. The other one, we've got 3x plus 4 equals negative 3x plus 7. We add 3x to both sides of the equation. 6x plus 4 equals 7. We subtract, let's try subtracting 4 from both sides. 6x equals 3. Divide by 6, x equals 1/2. Let's check 1/2 and see if that works. 3 times 1/2 plus 4 equals the absolute value 3 times 1/2 minus 7. Okay. 3 times 1/2 would be 3/2. 3/2 plus 4 would be 3/2 plus how many halves? Well, let's see. If we take 4/1, multiply it by 2/2, we get 8. So we get 11/2. But the absolute value of 11/2 is what? 11/2, right? Okay. On the right side, 3 times 1/2 is 3/2. And then we've got what? 3/2. Let's see. These should all have had absolute value bars on them. 3/2 minus 7, which is 3/2 minus something over 2. We're going to multiply by 2/2, so minus 14, which gives us negative 11/2. But the absolute value of negative 11/2 is 11/2, so it checks and it checks. So in this case, we had two equations, but only one of them led to a solution. The moral of this story is check your work. All righty. So once again, if you have an absolute value equation with one absolute value, isolate it completely before you decide how to split it up. If you have two absolute value terms, you want them separate, one on each side of the equation. If it's set equal to a positive number, you're going to have two equations. If it's set equal to 0, you're going to have one unique equation. If it's set equal to a negative number, you can set up the two equations, but you're going to get no solution. Always check your work, because in a scenario like the one we just did, one of them works, one of them doesn't. All right, having said all of that, do you have any questions before we call it a day? All right, we'll call it a day. I will stop the recording.